So welcome to this latest video 162 Maths, and in this video we'll go through some common questions on geometry and measure on the higher GCSE syllabus. Now a copy of the questions is available for you to download and attempt before watching through this video that goes through how to get the correct answers by clicking on the link in the description, where I'll also include a question breakdown so you can see which topic each question is based on. Now before we get started working through these geometry and measure questions, it's important to note that not every single topic in geometry and measure is taken by the questions that we're about to go through in this video. So please do mindful that there are other topics and other questions that could be asked. This should not act as your sole revision for geometry and measure, but more of a case of identifying any particular topics of the more popular topics as your weakness. So looking at question 1, which is looking at loci, and if I just zoom out a little bit, hopefully we can see the whole of that question, which is here. It says that you will need a ruler and a compass to answer this question. The diagram shows a plan of a garden. The hedge DE is 20 meters long, and it says a tree is to be planted so that it is 20 meters from D and the same distance from the wall as it is from the fence. And it says construct your position of the tree on the plan. So for this, what we need to do is if we take these two bits of instruction that we've got, so let me just highlight this bit here first. So for this, what we need to do is we need to draw a circle from D with a radius of DE. So if I just write down here, so what you need to do is to draw a circle with center D with a radius of DE. Now there's no scale on this, so what I need to do is then with the compass and the pencil is set the pin on D and the pencil at E, and that should give you the radius for that particular circle you're about to do. Then for this second instruction, for the same distance from the wall to the fence, what I need to do is I need to do an angle bisector of the wall and fence. And what I'll do now is I'll revert to my camera and actually show you how to answer this particular question. So with this question, the first thing you want to do is set up your compass and pencil. So to set up your compass and pencil, just make sure that your compass is closed and the pin of the compass is as close as possible to the tip of the pencil. And you also want to make sure that your compass has got it's not too loose basically. Then what you then need to do is set the pin on D, and then you want the radius of the circle that you're about to draw to be the same as DE. So just, it can be a little bit fiddly, but what you should have is something that looks like this. And then what you want to do is to draw your arc so it goes from E all the way to that back wall. So you should have something that looks like this. Now the next thing for us to then do is to do an angle bisector of the wall and the fence. So for an angle bisector, what you want to do is just set your compass and your pencil at any particular length, so anything that's comfortable for you to draw an arc. And then what you then want to do is set the pin in the corner and then draw the arcs where it crosses the fence and when it crosses the wall. Then the next thing for you then do is to put the pin on the intersection point of the arc you've just drawn on the wall and draw an arc then in the middle. Then you then need to repeat the process with the intersection point of the one on the fence, and again making sure you've not adjusted the compass, and you should end up with something that looks like this. Now what I'm now going to do is just put a little dot on the intersection point and the dot in the corner of the wall and the fence, and then with a ruler what you then want to do is to draw a line through those 2 points, and that then is your angle bisector, but also drawing a line which is equidistant from the wall and the fence. Now where the tree is to be planted is basically where the arc from D joins that line you've just drawn, which is here. So I'm just going to put a little dot there, and that's where the tree is to be planted. Then moving on to question 2, it says use the steps to construct a circle passing through the vertices of the triangle ABC. And it says construct a perpendicular bisector of AB, construct a perpendicular bisector of AC and use the point of intersection of the bisectors as a centre of a circle, and then draw a circle through ABC. Show your construction arcs clearly, so do not rub out any of your arcs that you do. So again, what I'll do is I'll revert to the camera and I'll actually show you how to work through this particular question. Then talking you through question 2. So what we need to do is basically follow each of these key points. So the first thing we need to do is to draw a perpendicular bisector of A and B. Now to do an angle a perpendicular bisector between 2 points, you want to set your compass so that it's more than halfway of the line that you're trying to bisect. So I would say that's pretty much more than halfway. So what I do is I draw an arc. We might want to draw a big arc and then repeat the process on the other point. So I started with B and I'm going to start to A. And with the 2 intersection points, which I've got here and here, I'm then going to draw that line. Now the line doesn't need to be of any particular length, but it definitely needs to go through the 2 intersection points of your 2 arcs. The next thing that's then left for me to do is to construct a perpendicular bisector of A and C. So again, this time I'm going to set the compass so it's more than halfway. Now you might choose to set your compass and the pencil a different length. I'm probably going to keep mine the same. So I've got this point here already drawn. I'm just going to extend it further this way. I then do the same from C, and what I'm wanting is those 2 arcs to cross. Now the 2 intersection points of the perpendicular bisector of AC is going to be here and here. So then all that's left for me to do is to draw a line connecting those 2 points. Now the question then says, using the intersection point of those 2 perpendicular bisectors as the centre of a circle. So then what I'm going to do is put the pin on that point. I'm going to put the pencil on A, and what I should find is while I'm swinging the pencil around, it should go through C and B, which it does. And then just need to complete the circle. So you should end up with something that looks like that. Now looking at question 3, it says the straight lines AE and BD intersect at C, and the question is asking us to prove that triangles ABC and EDC are congruent. Now to prove whether triangles are congruent, you either need to show that 2 sides and an angle are the same, or 2 angles and a side are the same, or 3 sides of a triangle are the same. Now another good practice is to make sure that you identify which triangles are actually in question. So here I've got triangles ABC, which I'm going to highlight in green, and I've got triangles CDE or EDC, which I'm going to highlight in orange. So straight off the bat, I can see that I've got a side on each of those triangles that's 5 centimeters. So I could start by writing that BC is equal to CD, which is 5 centimeters. So just a reminder to myself, I'm going to write that I've proved that a side is the same on both those 2 triangles. Now I also know that this angle here is going to be equal to this angle here, because BD and AE are straight lines as stated at the start of the question. So here I've got opposite angles. So angle ACB is going to be equal to DCE, and it's always good to write down your reason, and because they are opposite angles. So then I've proved that an angle in each of those triangles is the same. Now the next thing that's left for me to do is to either prove another side or another angle is the same. Now if I take a closer look at triangle ABC, I can see that I've got 2 sides and an angle. So what I can then do is use the cosine rule to find what that third missing side is, which is AC. So here, if I just remind myself what the cosine rule is, so it's a squared equals b squared plus c squared minus 2bc cos a. Then if I establish the parameters, so I've got a equals x, b equals 3, c equals 5, and capital A is 120 degrees. So then substituting numbers into this formula, I get x squared equals 3 squared plus 5 squared minus 2 times 3 times 5 times cos of 120. Now if I type in all of this in my calculator, press equals, I get x squared equals 49, and so therefore x equals 7. So if I write that as 7 centimeters, and then lo and behold, I can see that I've got a side of 7 centimeters on each of those triangles. So AC equals CE, which equals 7 centimeters. So there I've proved another side. So that in my conclusion, I can write as SAS, triangle ABC, and triangle EDC are congruent. Then moving on to question 4, it says that OABC is a square of side 8 centimeters, OPQR is a square of side 6 centimeters, and angle ROC is 30 degrees. Prove that the triangle OCR and triangle OPA are congruent. So again, little reminder, either proving 2 sides are the same, 2 angles are the same, or 3 sides are the same. So again, highlighting the triangles, I've got ORC. So ORC is this triangle here, and triangle OPA is this triangle here. Again, excuse the poorly straight lines I failed to do there. So let's have a look at this then. So just labeling, because it says that I've got 2 squares. So looking at the square of PQOR, that this is also going to be 6 centimeters. So therefore PO is equal to OR, which is 6 centimeters, and they're the same, or they're a side on the same square. Now, it's always good practice for you to write down what you've shown and why it is. So there I've showed that a side is the same. Then if I look at the other rectangle, the square, I can see that this length here, which is AO, and OC is 8 centimeters, and again they're sides on the same square. So again, I've proved another side is the same. So the next thing that's left for me to then do is to prove angles. Now if I look at this angle of AO or C, I know that this angle here is 90 degrees, so I can then work out what this angle here is, which is 60 degrees. And then from this I can then know that this angle here is also a right angle. So then to work out what this angle here is going to be, I do 90 take away 60, which is 30 degrees. So therefore I can see that I've got 2 angles that are now the same, that are in both those triangles. So here I've got angle POA. Let me just make sure that O doesn't like a Q. So POA and angle ROC are both equal to 30 degrees. So there I've proved an angle. So in terms of my conclusion, I can then write as SAS, triangle ORC and triangle APO are congruent. And there we go. Then moving on to question 5, it says describe fully the single transformation that maps shape A to shape B. So we're going from this shape to this shape. Now straight off the bat, we know it's going to be an enlargement because the shape has changed in dimension. So we know it's an enlargement. So the next thing for me to then state is the scale factor. Now we're going from a big shape to the small shape. So it's going to be decreasing in size. So it's going to be a proper fraction. So it's going to be the new shape, which is 2, over the length of the corresponding side on the big shape, which is 6, which is a third. And the only thing that's left for me then to do is to find the center of enlargement. So what I then need to do is draw lines to the corresponding points. So if I join those 2 peaks together like so. So I know it's going to be somewhere on that line. Then if I change the colour, just make it stand out a little bit. Let's go for this point here, which again, a little bit fiddly on the computer. And if I go, it makes it go through the corresponding point on shape B. And I can see that most likely my centre of enlargement is going to be this point here. But just to confirm, let's just draw a third line. Going through the point, as you can see, that pretty much confirms it. So then the centre is at 10, 10. Then moving on to question 6, it says enlarge triangle ABC by a scale factor of -2 from centre for 1. Now if I start by labelling my centre as O, then what I would then want to do is just write down the column vectors of going from O to each of those particular points. So if I write down the column vectors of each of these, so O to A is 4, 0. O to B is 2, -2. And then O to C is 3, -2. Now once I've done that, if I then multiply each of those by the scale factor, and I then work it out, so that's going to be -8, 0. This is going to be -4, +4. And this one's going to be -6, +4. And this is going to be O to A dash, O to B dash, and O to C dash. Then starting with O, let's just use a different colour. So for the first one, I'm going -8, 0, which is left 8 places, which is here. And that's where my A dash is going to be. Now B dash is going to be -4, so it's 4 to the left, then 4 up, which is here. So that's where B dash is going to be. And then C dash is -6 and 4 up, which is here. So that's going to be C dash. Then all that's left for me then to do is to join those points up. And again, hopefully you should be using a ruler, but just to save a bit of time, I'm going to draw it, go freehand. And then if you want to check to make sure you've done it correctly, let me start by just using a different colour. And then what you then want to do is, if I just start by connecting that point there. Now you don't need to do this for every single point, but I'd say do it for at least 2. So there's one projection line. And then drawing my second projection line. Let's just do that there. And I would, in your exam, always draw your projection lines because it just confirms that what you've done is correct. And as you can see, it's absolutely spot on. Then, and again, but please do make sure that you are using a ruler in terms of drawing your lines because it should be straight. So let me just show a good example of doing just that without deleting my projection lines. So let's do it in red. And there we go. So then moving on to question 7, it says triangle PQR is shown when PQR is reflected in the line. P and R are invariant points. Circle the equation of the line. Now, invariant basically means do not move. So in order for those 2 points not to move, so this point not to move, it basically means that the reflection line must be going through each of those 2 points. So this here is my reflection line. Now the question is asking me to work out the equation of that line, and that line is y equals -x. Then moving on to question 8, it says, here is a circle. Circle the word that describes the shaded part, and that is a segment. Then for question 9, it says, and let's just zoom in so we can see that a bit clearer. It says P, Q, R and S are points on a circle. PXR and QXS are straight lines, and PX equals SX. Prove that QS is not the diameter of the circle. Now, in terms of the information that's given to there, that's just basically confirming which circle theorems you're going to be using and just clearing up some of the facts of that fact that you've got straight lines and certain points go through each other. Now, when you're doing any form of geometric proof, you always want to state a fact. So if QS is the diameter, then the opposite angle, then angle QPS must equal 90 degrees. So that's what we're going to first of all establish first. So I'm going to work out what this angle here is collectively. Now, straight off the bat, using one of the circle theorems, I know that this part here is going to be 27 degrees. And the reason why I know that, now it doesn't state in the question that it wants me to show proof, but as you can see, if I just highlight it, you can see I've got a bow, and angles that share the same arc are going to be equal. So this part here is going to be 27 degrees. Now I then know that this triangle is an isosceles triangle. So this side here is the same as this one. So if this angle here is 50, I can then work out this angle by doing 180 minus 50 divided by 2. Now 180 take away 50 is 130, and 130 divided by 2 is 65 degrees. So therefore, angle QPS is going to equal 65 plus 27, which is 92 degrees. So as QPS is not 90 degrees, QS is not the diameter of the circle. So moving on to question 10, it says in the diagram AB equals BC, and the question is asking us to prove that ABCD is in a cyclic quadrilateral. Give your reasons for any statements that you make. So first things first, let's give our proof of what we know about a cyclic quadrilateral. So if ABCD is a cyclic quadrilateral, then opposite angles add up to 180 degrees. Now we know that triangle ABC is an isosceles triangle, so because we've got two sides the same. So this angle here is going to be X, and the reason for that is because it's angles in an isosceles triangle. Then that means that this angle here is going to be 180 minus 2x, and the reason for that is because angles in a triangle equal 180 degrees. Now if I take these two angles here, so this angle here and this angle here, and add them together, then I get angle ABC plus ADC should equal 180 degrees. So if, and again this is just reiterating that statement, so if I add those two angles together, so ABC is 180 minus 2x plus angle ADC, which is 2x, and if I simplify that expression I get 180, so therefore ABCD is a cyclic quadrilateral. Then moving on to our next question, it says the diagram shows the net of a square base pyramid, and it says that the area of the square base is 36. Work out the area of one triangular face. So let's first of all start by labeling what we know. So if this square is 36 centimeters square, then that means that one of the sides must be 6. So then if I take this triangle, now the area of a triangle is either going to be base times height divided by 2 or a half AB sine C. So then if I take this triangle here to start with, so let's take this triangle here and just take it out of context again. So this is 70, this is 6. Now if I halve that triangle, then this side here is going to be 3. And what I'm wanting to know is to work out what the height of that triangle is. So then using this triangle here, which there is x, this is 70, and this is 3, I can then use tan x, or tan 70 rather, because I've already used the letter x, so tan 70 equals x over 3. Let me just write that out a little bit better. And then, so x equals 3 times tan 70. So x equals, and it's going to be 7 or 3 tan 70. I'm just going to leave it as that in exact form, but if I wanted to write it as a decimal, reaching for my calculator, it gives me an answer of 8.24. Now that is the height of one triangle. So then going back to this triangle, we've got this angle here of 70. I know that this here is 3 tan 70 and this length here is 6. So then using base times height divided by 2, so the area is going to be 3 tan 70 multiplied by the base, which is 6, all divided by 2. And if I type that all into my calculator, so I've got 3 tan 70 multiplied by 6 divided by 2, gives me an answer of 24.7, and that's to 1 decimal place, and the units are centimetre square. Then moving on to question 12, it says that a solid shape is made by joining 2 cones. Each cone has the same radius. And it says that one cone has the slant height equals 2 times the radius, and the other cone has a slant height of 3 times the radius. And it says the total surface area of the shape is 57.8 pi. The curved surface area of a cone is pi RL, where R is the radius and L is the slant height. Work out the radius. So first of all, let's just work with the total surface area. Now total surface area is the area of the 2 cones, so it's the surface area of the big cone plus the surface area of the small cone. Now I know that the total surface area is 57.8 pi, and that's equal to, then if I use this formula to work out the area of the cone, so here the big cone, well the big cone has got a slant area of 3r and the small cone has got 2r, so that equals L. So then here I've got pi times the radius of the small cone, which is r, times the slant height, which is 3r. And then I need to work out the surface area of the small cone, so that's going to be pi times the radius, and it's got an L value of 2r. Now simplifying all of this, then what we end up with is 57.8 equals, and it's going to be 3r squared pi plus, and it's going to be 2r squared pi. I've missed out the pi of the 57.8, so let me just write that in. And here we've got 57.8 pi. Then if I expand the brackets, I get 57.8 pi equals, and I've got 3r squared pi plus 2r squared pi, which then becomes 57.8 pi equals 5r squared pi. Then at this stage I can then cancel the pi's because both sides have got pi, and so therefore 57.8 divided by 5 equals r squared. So therefore r equals the square root of 57.8 divided by 5. And if I type that all into my calculator, I get an answer of 289 over 25 square rooted, which gives me an answer of 17 over 5, or as a decimal, 3.4 centimeters. So any of those would be absolutely fine. Then moving on to question 13, it says the volume of a sphere is 4/3 pi r cubed, where r is the radius. A container is a hemisphere with a radius of 30 centimeters. Sand fills a container at a rate of 4,000 centimeter cubes per minute. Does it take less than a quarter of an hour to fill the container? So first things first, what we need to do is work out the volume of the hemisphere. Now the formula for this, now it tells me the volume of a sphere, so it's going to be 4/3 pi r cubed, all divided by 2. Now it tells me that r equals 30. So if I substitute that in, I get 4/3 times pi times 30 cubed, all divided by 2. Now if I type that all into my calculator, I get an answer of 18,000 pi. Now I'm going to leave my answer as that because the number is quite big. So then the next thing that's then for me to do is work out the time. Now it tells me that the rate is 4,000 centimeter cube per minute. So then if I then do, so in terms of the time, it's going to be 18,000 pi divided by 4,000, because I want to work out how many minutes there are. And that gives me an answer of 14.13 minutes. Now the question's asking, does it take quarter of an hour? Well, quarter of an hour is 15 minutes. So as 14.13 is less than 15 minutes, the answer then is yes, it takes less. Then moving on to question 14, it says this shape is made from two identical sectors. Work out the perimeter of the shape, give your answer in terms of pi. So looking at this, the thing that I need to work out is what this arc length here is going to be. Now the formula for arc length is theta divided by 360 multiplied, now because it's connected to the circumference of a circle, it's multiplied by 2 pi r. Now you could use pi times d, but because we're working with radiuses, it just makes it convenient if we use this formula here. So then working out this green length, what I've got is 150 over 360 multiplied by pi times the radius of that, which is 6. So it's going to be 6 times 2. Now if I type that all into my calculator, I get an answer of 5 pi. So then this green length here is 5 pi, and this length here is also going to be 5 pi because the sectors are identical. So then working out the perimeter, looking at all those 5 sides, well, I've got 5 pi plus 3 plus 6 plus 5 pi plus 3 plus 6. Then joining and simplifying all of this, I get an answer of 10 pi plus 3 plus 6 plus 3 plus 6, which is 18, and that's in centimeters. Then moving on to question 15, it says the diagram shows a sector of a circle with center O and a radius of 18. Work out the area of the shaded segment. So the shaded area, oh, what's happened there? So the shaded area is always the big shape, take away the small shape. So the shaded area equals the area of the sector minus the area of the triangle. Now the area of the sector is, let me just write down the formula. So area of a sector is theta over 360, and because sector is connected to area, it's times pi r squared. Now the area of the triangle that I'm going to be using is going to be half AB sine c. And the reason why I'm going to use half AB sine c is because I don't know the height of that triangle. So looking at the area of a sector, it's going to equal 40 over 360 multiplied by pi times 18 squared. And if I type that all into my calculator, I get an answer of 36 pi. So then, working out the area of the triangle, it's going to be a half times 18. This is also 18 times sine 40. And if I type that all into my calculator, I get an answer of 104.1315928. So all that's left for me to then do is just take those two numbers away from each other. So in the shaded area is going to equal 36 pi minus 104.1 and whatever you've rounded it up to, and that gives me an answer of 8.97, and that's in centimetre squared, and that's to 2 decimal places. Or I could write 9, whichever you prefer in terms of your rounding, but always state what you've rounded it to if you have rounded end your answer. Then moving on to question 16, it says that ABC are similar triangles, and it says work out the value of x. Now for this, what you want to do is find the two triangles. So here I've got a large triangle in which I've got a base of 10 and a height of x plus 5. And then I've got my smaller triangle, which has got a base of 6 and a height of x. Now I then need to find the two corresponding sides, so I can then use that to work out the scale factor. So the scale factor is going to be 10 over 6, which is 5 over 3, which is not a nice decimal number, so I'm going to leave it as that. Now because I'm going from x is on the smaller shape, that if I then do the side on the big shape, so x plus 5, now divide by the scale factor, I'm going from big to small, so it's divided by 5 over 3, and that's going to equal x. Then if I take this over to the other side, and then multiply by 5 over 3, so I'm left with x plus 5 equals 5x over 3. Take the 3 over, in which I get 3x plus 15 equals 5x. Take the 3x over, in which I get 15 equals 2x, and then I end up with x equals 7.5 centimeters. Then moving on to question 17, it says solids x and y are similar. X has a volume of 64, y has a volume of 343. The surface area of x is 176. Work out the surface area of y. Well, for starters, if the volume scale factor is k cubed, which we know in this case is going to be 343 over 64, then k is going to equal the cube root of 343 over 64, which gives me an answer of 7 over 4. So then the length scale factor is going to equal 7 over 4, and that's what k is, and the area scale factor, which is k squared, is therefore going to be 49 over 16. So then to work out y, now we can see that y is the bigger shape, so we're going to need to do x times the scale factor. So here we've got 176 multiplied by 49 over 16. And if I type that straight into my calculator, I get an answer of 539. So the answer then is 539. Then moving on to question 18, it says all dimensions are in centimetres, and it says use Pythagoras' theorem to work out the exact value of x over y. So using Pythagoras, I know that x squared plus 7x squared equals 10y all squared. Now expanding the brackets out, I get x squared plus 49x squared equals 100y squared. This then equals 50x squared equals 100y squared. Then if I take the 50 over to the other side, I end up with x squared equals, and 100 divided by 50 is 2. So I get 2, and it's going to be y squared. Then if I take the y over the other side, I get x squared over y squared equals 2. Now I want to work out what x over y is, so if I square root both sides, I get x over y equals root 2. And moving on to question 19, it says work out the area of the trapezium. Now to work out the area of a trapezium, the formula is a plus b all multiplied by h divided by 2. So labeling this up, we've got a and b are our two parallel sides. I don't know what h is, so I need to work that out first. Now, if I draw this line here, which is also the height, I'm just going to call that x, and I take this triangle out. Now, this is what I'm wanting to know. I know this is 64, and this length here is going to be the difference between these two numbers, which is 4. So then from this, I can use trig to work out what that is. So I'm going to be using tan. So I know tan 64 equals opposite over adjacent. So x equals 4 tan 64. Now, because that's part of a question, I'm going to leave my answer as 4 tan 64. But if you did want to convert it into a decimal, you should have an answer of 8.201 blah blah blah. Now here then, to use this formula, the area is going to equal 11 plus 15 multiplied by 4 tan 64, or you can use 8.21, it's entirely up to you, and that's all divided by 2. And if I type that all into my calculator, I get an answer of 106.6 centimeters square, and that's to 2 decimal places. I'm just neating that up. Then moving on to question 20, it says the length of a diagonal of a cuboid is 20 centimeters. The diagonal makes an angle of 24 degrees with the base. The area of the base is 150 centimeters square. Work out the volume of the cuboid. So to work this out, the volume of a cuboid is obviously length times the width times the height, but it's also, so let me just write that down, so length times the width times the height, or it's the cross section or area, which is basically the area of a face multiplied by the height. Now in the question it tells me that the area of a base is 150, so the base of this here, which I shouldn't really use that colour because it kind of demoralizes the whole question. Let's do this in highlight. So this area here is 150 centimeters square. So if I can then work out what this length here is going to be, which I'm not going to call h, I'm going to call x. Now from this, I then know that the diagonal of the length cuboid is 20 centimeters. So then taking that triangle out, I know this is 20, this is x, and this angle here is 24. So then using a bit of trig, which I'm going to be using sine. So here I've got sine 24 equals x over 20. So x equals 20 sine 24. And if I type that into my calculator, so 20 sine 24, I get an answer of 8.13 blah blah blah. Now to work out the volume, it's going to be 150 multiplied by the height, which is 20 sine 24, or 8.31. And if I just type that into my calculator, I get an answer of 1220.2, and that's centimeter cubed, and that's been rounded to 1 decimal place. Now in the mark scheme, they would accept any answer that's between 1215 to 1221. It all depends on the rounding that you've used. I've used the exact value, hence why it's probably near the more upper end of that range. Then moving on to question 21, it says show the value of 5 sine 30 times cos 30 times 8 tan 30 is an integer. Well, for this is using exact values of trig. So sine 30 is equal to a half. Cos 30 is equal to root 3 over 2. And tan 30 is equal to 1 over root 3. Now it is also root 3 over 3, so whichever you prefer to use is entirely up to you. Now I'll go show you both ways. So using tan 30 equals 1 over root 3, then what we get is 5 times a half multiplied by root 3 over 2 multiplied by 8 times 1 over root 3. Now multiplying things out, I get 5 over 2 times root 3 over 2 times 8 over root 3. Now just multiplying the numerators together, I get 40 root 3 over 4 root 3, in which then the root 3's cancel out, and I've got 40 divided by 4, which equals 10. Then if I use the other variation of tan 30, so using tan 30 equals root 3 over 3, then I end up with 5 times a half, just like I did before, multiplied by root 3 over 2, multiplied by 8 times root 3 over 3. Then simplifying that, get 5 over 2 times root 3 over 2 times 8 root 3 over 3. 5 times 8 is 40. Root 3 times root 3 is root 9. And 2 times 2 is 4. Times 3 is 12. Now root 9 is 3. So that then becomes 40 times 3, which is 120. So that then becomes 120 divided by 12, which equals 10. And as you can see, I get the exact same answer. Then moving on to question 22, it says ABC and ACD are triangles. Work out the size of angle X. So angle X is just there. Now if I take this triangle here, I first of all need to work out what AC is going to be. So if I take that triangle out, then what I end up with, if I call this side X, that's 18 and this is 49. Then I'm going to use tan. So tan 49 equals X over 18. So X equals 18 tan 49. Now again, if you want to type that into your calculator, I get a decimal number of 20.706. But instead I'm just going to label that as the exact value. So I'm going to label this side here as 18 tan 49. Now if I then take this triangle out, ABC, and just label the bits that I know. So I know this angle here is X, this angle here is 35, this length here is 20, and this side here is 18 tan 49. I can then use the sine rule, in which I've got 18 tan 49 or 20.7, whichever you prefer, over sine X equals, and it's going to be 20 over sine 35. They're doing a bit of cross multiplying. You end up with 20 sine X equals. Now, I probably would opt for using decimal, because I think otherwise it might seem confusing. But if you're fine with it, then that's absolutely fine. So I'm going to end up with 20.706 multiplied by sine 35. I then take the 20 over, so I get sine X equals 20.706 multiplied by sine 35, all divided by 20. And then if I then do X equals the inverse sine of the answer on my calculator, or basically this whole fraction there, I get an answer of 31.9 degrees. Now, any acceptable answer is 31.8 to 31.9 degrees. So if your answer is slightly off from mine, as long as it's within that range, it's all good. You would get full marks for it. Moving on to question 23, it says that a shape is made by joining a triangle ABC to a semicircle with diameter AC. Work out the total area of the shape. Well, the total area of the shape is the area of the semicircle plus the area of the triangle. Now, to use some of the formulas, the area of a semicircle is equal to pi r squared divided by 2, and the area of the triangle is going to be a half AB sine C, because I don't know the height of that. So if I start by working out the area of the triangle, well, in order to work out the diameter of the semicircle, I need to work out what AC is first. So what we need to do is find AC. So I'll start by calling that X. Now for this I'm going to use the cosine rule because I know three sides and an angle. So the cosine rule is a squared equals b squared plus c squared minus 2bc cos a. So labelling the sides up, I get a equals x, this is capital A, that's B, and that's C. It doesn't matter if you've labelled BC the other way around, it doesn't really make a difference. So here we get x squared equals 8 squared plus 10 squared minus 2 times 8 times 10 times cos of 114. Now if I type that all into my calculator, I get an x value, or x squared value of 229.077. So therefore x equals 15.135. Now then to work out the radius, so therefore the radius is going to equal 15.135 divided by 2. So then working out the area of the triangle, that's going to be a half times 8 times 10 times sine of 114, and that gives me an answer of, let's just work that out now, of 0.5 times 8 times 10 times sine 114, and it gives me an answer of 36.541 blah blah blah. Then the area of the semicircle is equal to pi times 15.135 over 2 squared, all divided by 2, and that gives me an answer of 89.958. So all that's left for me to do is just add these two numbers together, in which I get a total area of 126.5 centimetres square, and that's to one decimal place. And in the mark scheme, they would accept any answer between 125.99 to 126.57. Then moving on to question 24, it says work out the area of the parallelogram. Well, to work out the area, it's basically the height times the base. So first things first, what I need to do is I need to work out what that length there is going to be. Now if I start by just taking that triangle out and label this length that I want as x, so in other words it's going to be x times 16, but if I take that triangle out I get 72, that's 12, and that's x. So I'm going to be using, that's the opposite, that's the hypotenuse, so I'm going to be using sine, so sine 72 equals x over 12, so x equals 12 times sine 72, so x equals, and it's going to be, I'm just going to leave it as 12 sine 72, but if you want to work out what it is as a decimal, we get sine 72, we get 11.41. So then working out the area, it's going to be 16 times 12 sine 72, or 16 times 11.41, in which we get a final answer of 182.6, and that's to one decimal place. And the units are stated in the question, so don't hate me for not writing them. Then moving on to question 25, it says that A is a column vector of minus 3, 2. B is a column vector of 1, minus 5. Work out A minus 3B. So it's going to be minus 3, 2, minus 3 lots of 1, minus 5. Now that equals minus 3, 2, minus 3, minus 15, which equals minus 3, minus 3, and 2 minus minus 15. Now minus 3 minus 3 is minus 6, and 2 minus minus 15 is positive 17, which is our first option. Then moving on to question 26, which is our last question. It says in the triangle JKL, M is the midpoint of JK, JN to JNL is in the ratio of 3 to 2, KL equals 7A, and NL equals 4B. Work out JM in terms of A and B, give your answer in its simplest form. So first things first, let's look at this ratio. So we know that the ratio of J to N is 3 parts going in this direction, and this part here is 2 parts. Now it also tells us that so therefore using this information here, we know that if 2 parts equals 4B, then 1 part is going to equal 2B, so therefore 3 parts is going to equal 6B. So this J to N is 6B. Then I can then work out what J to M is going to be. So J to M is going to be half of J to K, and J to K is equal to, well, it's going to be 6B plus 4B, which is 8B, and then minus 7B. So therefore then, half of JK is going to be 4B minus 3.5B, which I've missed out an A there, so that should be an A, not a B. A, and that's an A, and there is my final answer. So therefore J to M is equal to 4B minus 3.5A. You could write it as 7 over 2, that's entirely up to you, but that there is our last question and the end of this practice paper.